66 million years ago, an asteroid ended the age of giant reptiles. Tyrannosaurs disappeared. Triceratops disappeared. Pterosaurs vanished from the sky, while mosasaurs and plesiosaurs were wiped from the oceans. Yet in the wreckage, crocodile relatives were still sitting beside rivers built around the same basic ambush strategy they use today. That sounds almost absurd. Crocodiles are large predators. They grow slowly, spend years reaching adulthood, and depend on other animals for food. Those are not traits you would normally choose for surviving a global ecological collapse. A small seed-eating bird makes sense. A burrowing mammal makes sense. A heavily armored reptile waiting for meat beside a ruined swamp seems like it missed the extinction memo. But the first mistake is imagining that crocodiles simply walked through the disaster untouched. Late Cretaceous crocodiliforms were far more varied than the animals alive now. Some ran on land. Some had narrow fish-catching snouts. Others were heavily built predators, small omnivores, or bizarre forms with teeth suited for diets that were not strictly carnivorous. Many of those lineages disappeared. Modern crocodilians descend from only part of a much larger experiment, and evidence indicates that the extinction hit crocodilomorph diversity hard. So the real question is not why crocodiles were immune. They were not. It is why a few branches survived when so many other large reptiles did not. The answer begins with what happened after impact. Dust, soot, and aerosols reduced sunlight. Plants and plankton suffered. Food chains built on fresh plant growth began to fail from the bottom upward. Large active animals were trapped by their own operating costs. A giant predator did not just need one meal. It needed a landscape that kept producing prey, and that prey needed functioning vegetation beneath it. Crocodilian bodies run on a cheaper budget. As ectotherms, they do not constantly burn energy to maintain a high internal temperature. A crocodilian can remain inactive for long periods and tolerate gaps between meals that would be disastrous for a similarly sized warm-blooded predator. That did not make starvation harmless, but it stretched the clock. When food became rare, needing less of it could decide which animal was still alive when conditions finally began to improve. Even that is only part of the explanation. Low metabolism did not save every cold-blooded giant, and some enormous reptiles with aquatic lifestyles still vanished. The surviving crocodilian lineages also happened to live around one of the few kinds of ecosystems that did not collapse in quite the same way as forests, plains, and open oceans. The next clue was in the water. Rivers, lakes, and wetlands were still damaged, but many of them could keep producing food without depending entirely on sunlight-reaching living plants. Dead leaves, drowned animals, rotting wood, fungi, microbes, and organic debris could feed small invertebrates and bottom-dwelling organisms. That material formed what scientists call a detritus-based food web. It was not healthy in the normal sense, but it could keep moving energy through an ecosystem after photosynthesis had been badly reduced. This gave freshwater animals a different set of options. Fish could feed on aquatic invertebrates. Turtles could eat plants, carrion, or small animals. Crocodilian relatives could take whatever became available near the shoreline. A dead fish was food. A struggling animal was food. A carcass washed into the river was food. They did not need to chase herds across a functioning landscape. Water also softened some of the immediate damage. It could shield animals from rapid temperature changes, surface fires, and the harshest conditions above ground. Crocodilians could remain partly submerged, rest in sheltered banks, and reduce activity when conditions were poor. This was not a magical bunker. Rivers could dry, water chemistry could change, and aquatic food chains could fail. But living at the border between land and water gave survivors more places to hide and more sources of food to exploit. Their feeding behavior mattered just as much. Modern crocodilians are famous for killing large prey, but they are not specialists that require one exact animal. Depending on size and habitat, they eat fish, amphibians, reptiles, birds, mammals, crustaceans, insects, carrion, and occasionally fruit. Their extinct relatives were even more diverse, but the lineages that made it through the extinction appear to have included flexible semiaquatic predators rather than forms locked into narrow ecological roles. That flexibility matters during a catastrophe. A specialist can be extremely successful while its preferred food exists. Remove that food, and its elegant adaptations become expensive decorations. A generalist may be less efficient at any single task, but it has more ways to remain alive when the menu collapses. Crocodilians also reproduced on land, laying eggs in nests near water. That exposed them to danger, but it avoided dependence on open ocean breeding grounds or complex marine food chains. Young animals were small, ate small prey, and occupied a different ecological level from adults. A hatchling did not need the same resources as a 4-meter predator. Still, none of these traits guaranteed survival. Many freshwater reptiles vanished too. The final difference was not one superpower, but a particular combination of low energy demand, shelter, broad diets, and a body plan that could keep working while the world became smaller, darker, and poorer. That combination explains why some crocodilian lineages crossed the boundary, but it also explains why survival did not preserve the old world. The forms that emerged on the other side were not a random sample of everything crocodile relatives had once been. The extinction filtered them. Large terrestrial hunters, unusual plant eaters, and many specialized forms disappeared. The survivors were mostly animals whose lives already matched the conditions of collapse. This is why saying crocodiles survived because they were perfectly adapted can be misleading. They were not adapted for asteroid impacts. They had traits that happened to remain useful when food webs broke apart. Evolution does not prepare animals for disasters it cannot predict. It produces bodies that work under existing conditions, and sometimes those same bodies also work when the rules suddenly change. Size mattered too, but not in the simplest way. Some crocodilians can grow very large today, yet the individuals and species that survived the extinction were probably not all giant monsters. Smaller animals need less food, reach shelter more easily, and can live on prey that remains available near the bottom of a damaged food web. Once ecosystems recovered, surviving lineages could increase in size again. The giant crocodilians of later eras were not proof that enormous bodies were immune. They were proof that size could return after the crisis had passed. Their survival also came with limits. Crocodilians remained tied to warm climates, access to water, suitable nesting areas, and enough prey to support them. They never reclaimed the full range of forms their relatives had occupied before the extinction. Birds took the skies. Mammals expanded across the land. Crocodilians held on most successfully in rivers, lakes, swamps, and coastal wetlands, where their old strategy still worked. That strategy is brutally efficient. Stay still. Spend little energy. Let prey come close. Eat when the opportunity appears. Rest when it does not. A crocodile can look primitive because its body plan has changed less dramatically than those of many other animals, but that does not mean evolution stopped. Modern species are the surviving results of millions of years of filtering, adaptation, and loss. So crocodiles did not survive while every other giant simply failed. Most crocodile relatives failed too. The lineages that remained were the ones best positioned for a world with less food, fewer stable habitats, and long periods of uncertainty. Their greatest advantage was not strength, armor, or a powerful bite. It was the ability to keep functioning when almost everything around them stopped. Nature does not always reward the most dominant animal. During collapse, it often rewards the one that can afford to wait. For another example of how survival can reverse the usual balance between hunter and hunted, watch Why Were Some Ancient Prey Worse Than Predators? Thanks for watching.